Welcome to Conic Sections, Ellipses. In this tutorial we're going to look at the definition of an ellipse. We will be looking at the ellipse placed in the XY axis system. We're going to be looking at equations of ellipses within the XY axis system and see how to deal with specific problems. An ellipse is made when a plane intercepts a cone. Of course, there's other shapes that are made, but we're going to specifically be looking at the ellipse today. If you were to take two pins from your house and tie a string to each of the pins, put those pins in the wall and pull the string tight with a pencil, then as you pull the string tight with the pencil and move your way around the two pins, the shape that you would make would come out to be an elliptical pattern. Let's look at the definition. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points, f1 and f2, is constant. The sum of those two distances, that was the string that we just dealt with. Those 2 points, f1 and f2, are known as the foci, or the focus points. Ellipses have a major axis, which is the longer, and a minor axis, which is the shorter. And the intersection of those two axes is the center. The ends of the major axis are known as the vertex points, or the vertices. We can come up with the equation of an ellipse placed within the XY system with the major axis along the x-axis. We can come up with an equation for an ellipse by showing that d1 plus d2 is equal to 2 times a. So let me explain what that means here. The sum of these two distances, d1 and d2, the string, is equal to 2 times a. And a is the distance from the very center all the way out to one vertex point. So d1 plus d2, that string, is equal to 2 times a. So that's like saying the major axis, right? If we identify some points on the ellipse and use the distance formula for d1 and d2 and simplify, we're going to eventually come up with the equation of the ellipse centered at the origin, with the horizontal axis being the major axis along that x-axis. We're going to be dealing with two equations right now, one with the major axis at the x-axis and the other with the major axis along the y-axis. Essentially, if your bigger value is underneath x, then your major axis is along the x-axis. If your bigger value is underneath the y, then you're going to be dealing with the major axis along the y-axis. So the b value represents the distance from the center to the end of the minor axis. There's a Pythagorean relation that says that a squared is equal to b squared plus c squared. So what that means is if we have an endpoint on a major axis and an endpoint on a minor axis, we can figure out where the focus points are. So once again, this is our major axis, which is the a value, and this is our minor axis, which corresponds to the b value, and the c represents the location of the focus points. We want to find the vertices, foci, and graph this particular ellipse. First of all, we have to put this in the form of an ellipse. And As you recall from the previous page, we have a 1 right there. And so what I want to do is I want to get a 1 in the place of this 36. So I'm going to divide everything by 36. And what that does for me is that gives me x squared over 9 plus y squared over 4 equals 1. The 9 is larger than the 4, which means that the major axis is going to lie along the x-axis. The minor axis will lie along the y-axis. A squared is equal to 9, which means that A is going to be at plus and minus 3. That will tell us that the endpoints, the vertices, and we know that B squared is equal to 4, and that means that B is equal to plus and minus 2. That tells us the endpoints of the minor axis. Let's go ahead and plot these points and look at the graph. So based off the A and B values, I have plotted the vertices and the endpoints of the minor axis. That gives the graph. Now we just need to find the foci. And we have to use the fact that A squared is equal to B squared plus C squared. This means that C squared is equal to A squared minus B squared. Let's plug in A squared and B squared to solve for C squared, which gives us the C values, which gives us the focus points. Solving for C gives us plus and minus the square root of 5, which give us the focus points on the graph. The square root of 5 is approximately 2.2. We want to find an equation of the ellipse with foci 0, -3, and 0, 3, whose minor axis has a length 4. Sketch the ellipse and support your sketch with a graphing calculator. Let's go ahead and graph what we have so far and figure out what we actually have as far as what the graph tells us. So here we have our points drawn, and this tells us a lot here. We know that the minor axis gives us the B value. So this distance here gives us a B value that's equal to 2, which means that B squared is equal to a 4. We also know the C value. This distance here is 3, which means that C squared is equal to a 9. Because we have B squared and C squared, we can figure out A squared. A squared equals B squared plus C squared, which means that A squared is equal to 13 when we substitute in B squared and C squared. This tells us where the endpoints of the major axis are located. This tells us the vertices. Our vertices are located at 0, plus and minus the square root of 13, which is approximately 3.6. One thing I forgot to mention is that the focus point and the vertices are located along the same axis. They are both on the major axis. Let's finish up our problem by making the graph. We also need to come up with the equation of the ellipse, which I have shown here. Y squared is over the A squared value because the y-axis is the major axis and the x squared is over the b squared value because the minor axis is the x-axis. So that's the equation of our ellipse. We also need to support the sketch with a graphing calculator, which means we need to solve for y. So I've solved for y down here at the bottom, and what that means is we need to plug in two different y equals into the calculator, one for plus and one for minus. Let's see what happens when we enter this in the calculator. Let's check our work, make sure we're right. So I've entered in y1, y2, and we hit graph, and that gives us the equation of our ellipse. And unfortunately it doesn't connect there, but we can see that what we found pretty much matches up what our drawing looks like.